Hello, friends. In March 2003, the FBI arrested a 44-year-old man named Andrew Carlson. According to newspaper reports, this man had an unbelievable streak of luck. In the entire history of the stock market, no one had ever accumulated such a massive fortune so quickly. In just 2 weeks, he turned an $800 investment into $350 million. Naturally, the FBI suspected fraud, possibly insider trading. However, when they interrogated Andrew, he made a startling claim saying, "I am a time traveler. I've come from 250 years in the future. I knew exactly which stocks would rise and which would fall, so I invested accordingly, leading to these results." The FBI was astounded by his statement, certain he was lying, and determined to prove it. But as the investigation unfolded, they discovered something even more bizarre. Before September 2002, there was no record of Carlson's existence. What's more, on a Thursday in April, Carlson was scheduled to appear in court for a bail hearing, but he mysteriously vanished and was never seen again. So, was he truly a time traveler? Is time travel possible, or is it just a concept we see in movies? In today's video, we'll dive deep into the science behind time travel.
Wait, are you talking about a time machine?
You know the rules of time jumps, right?
Time travel, a concept that has been explored since the early 1900s.
I have no idea what we're talking about time.
In 1895, author H.G. Wells wrote the groundbreaking novel, The Time Machine. After that, the idea of a time machine, a device capable of taking us backward or forward in time, became a popular concept. Though purely science fiction, this novel inspired many philosophers and physicists to consider time travel seriously. This led to serious research papers on the subject and inspired countless films. Now, if we think about how time travel might be achieved in reality, it can be broken down into various methods. Let's explore these methods using examples from science fiction films. Time travel can occur in several ways. One-way travel to the future. You can journey into the future, but there's no coming back. This is portrayed in the movie Interstellar, where the character travels forward in time, while his family and others continue aging. By the time he returns, they have either passed away or aged significantly. Instantaneous time jumping. A person instantly moves from one point in time to another using a time machine. This concept is shown in films like Back to the Future and Looper. Time moving around the traveler. The time traveler remains stationary while time moves around them. This is depicted in the movie Harry Potter and the Prisoner of Azkaban, where a character uses the time turner. Slow time travel. This method is seen in the 2004 film Primer, where the time traveler must remain inside a box for a specific amount of time. For instance, if they wish to travel one day into the past, they must stay in the box for 24 hours. Traveling at the speed of light, time travel by moving faster than the speed of light. This idea appears in the 1978 Superman film, where Superman flies faster than light and goes back in time. Now, the question is, of these many concepts of time travel which are possible today, which might be possible in the future, and which are entirely unscientific, destined to remain fictional. If you're thinking that all these ideas are just nonsense, mere science fiction, think again. Some of these concepts are, in fact, scientifically possible even now. In reality, time travel can be of two types, traveling into the future and traveling into the past. Let's first discuss traveling into the future. The scientific explanations for time travel into the future are rooted in Albert Einstein's theory of special relativity, which introduced the idea of time dilation. Before Einstein, time was considered a constant, no matter where you were, whether on Earth, Mars, or near a black hole. Time was believed to move forward at a consistent pace, a concept famously championed by Isaac Newton. According to Newton, time remained constant regardless of your location in space, your speed, or your position. Einstein was the first to challenge this notion, saying, "No, Newton, you're wrong. Time is not constant. Instead, it's more like a river that can flow slowly or quickly depending on speed and gravity." Yes, you heard correctly. Einstein proposed that time could actually speed up or slow down based on changes in speed or gravitational force. This concept is known as time dilation. Just as the pupils in your eyes dilate, time also dilates when an object moves at a very high speed or when subjected to a strong gravitational force. Einstein discovered this concept, but explaining it, to put it simply, time can be affected by speed. If you start moving very fast, say in an airplane, the faster you go, the slower time will pass for you relative to a stationary object. For example, if you placed one clock on Earth and took another on a high-speed journey around the Earth, upon comparison, you'd notice a difference. The clock that traveled at high speed would lag behind the one that stayed on Earth due to time dilation. So, if we could build a rocket that could travel at the speed of light, and you spent 10 years in that rocket traveling at that speed, thousands of years would have passed on Earth by the time you returned. Simply put, traveling to the future is scientifically possible today. The only hurdle is that we don't yet have an aircraft or spaceship capable of traveling at such high speeds, not even close to the speed of light. However, as technology advances, we'll eventually develop faster spacecraft, and this concept will gradually become a reality. As of now, the person who has traveled the most through time is a human who has spent the longest time in space. Since astronauts in space travel at speeds of 28,000 kilometers per hour, they experience time dilation, though on a much smaller scale. Now, when you travel into the future, people on Earth will compare your age to theirs. If you're only 0.2 years older, you won't be upset, and you can thank the effects of time dilation. In this way, you can avoid getting angry by remembering that time can be affected by speed and gravitational force. Just as time is affected by speed, it's also influenced by gravity. The stronger the gravitational force in a location, the slower time moves there. For example, Earth's gravitational force is weaker than Jupiter's, while the Sun's gravitational force is even stronger than Jupiter's. Similarly, the curvature in the fabric of space-time increases with an object's gravitational force. The closer you are to an object with strong gravity, the slower time will pass for you. You can see this effect in the curvature of space-time. The greater the curvature, the slower time moves. This means that if you want to travel into the future, you should spend time near Jupiter, the Sun, or an even stronger gravitational object, such as a black hole. If you stay near a black hole, time will pass very slowly. This concept was also depicted in the movie Interstellar. If you recall, the main character lands on a planet near a black hole where every hour on that planet equals many years for those outside the gravitational field. This time dilation was scientifically accurate as shown in the film. However, it's worth noting that we don't yet know if a person could survive being so close to a black hole. Black holes are some of the most massive objects in the universe, so dense that not even light can escape their gravitational pull. While this idea was once theoretical, 3 years ago, a telescope captured the first image of a black hole, proving its existence. On April 10, 2019, the Event Horizon Telescope took this historic photo, which went viral as it was the first visual evidence of a black hole. Returning to time travel, there are two ways to journey into the future: by traveling at high speed or by staying near a massive gravitational object, like a black hole. Another method, often depicted in films, involves hibernation. For example, in the movie Passengers, characters travel in a spaceship and are placed in suspended animation for months or even years. Though this is science fiction, NASA is currently working on developing chambers for this purpose, and research is ongoing. One real-life example involves a man who survived for 18 days without water or food because his body entered a hibernation-like state. His body temperature dropped to just 22 degrees Celsius. Typically, a human wouldn't survive such a low temperature for long, but this man not only survived, but fully recovered. Medical reports indicated that his organs had entered a power-saving mode, protecting them from damage. This type of suspended animation could be further developed by NASA or other space agencies in the future. So far, we've discussed methods of traveling into the future. But what about traveling into the past? Is that realistically possible? As of now, traveling into the past isn't possible, though we can glimpse the past. Light takes time to travel from one place to another, and although light moves fast, it still takes years to cross vast distances. The light we see from distant stars is actually from the past, giving us a view into history. Famed physicist Stephen Hawking hosted a party on June 28, 2009, at the University of Cambridge, complete with balloons and champagne. The extraordinary aspect of this party was that everyone was invited, yet not a single person attended. Hawking had arranged this event specifically for time travelers from the future, hoping to see if anyone would arrive. This experiment was a playful attempt to demonstrate that traveling back in time is impossible. If it were, then surely time travelers would have shown up at the party. Einstein's theory of relativity doesn't completely dismiss the possibility of traveling into the past. If a wormhole, essentially a shortcut through space-time, could be created, it might theoretically allow for backward time travel. However, numerous paradoxes accompany the concept of time travel to the past, such as the well-known grandfather paradox. This paradox poses that if you went back in time and prevented your grandfather from meeting your grandmother, you might never be born, raising significant questions about altering the past and the potential creation of alternate timelines or parallel universes. In conclusion, although traveling back in time is riddled with logical issues and paradoxes, the notion of time travel into the future is scientifically plausible and may become more achievable in the future. And while movies have made time travel a popular concept, its reality remains speculative. Thank you, friends. If you enjoy exploring such mysterious topics, please subscribe to my channel, as the upcoming videos will be even more captivating.